Hello and welcome to a lesson on solving linear and quadratic inequalities. We'll begin with linear inequalities, and to start with we'll look at a basic inequality and see what kind of manipulations we can carry out without making the inequality invalid. So let's consider the inequality 4 is less than 6. Well, obviously that's a true statement. 4 is less than 6. What if we add something to both sides of the inequality? Let's add 1 to both sides. So the left-hand side would become 5 is less than 6 plus 1 is 7. Is that still a true statement? Yes, it is. And that would be true however much we added to each side. What about if we subtract from each side? Let's go back to the 4 is less than 6, take 1 from both sides, and we get 3 is less than 5. And we see that that again is a true statement. So we can subtract from both sides of the inequality and it still remains valid. Next, what about multiplying both sides by 2? 4 times 2 is 8, 6 times 2 is 12, and sure enough 8 is less than 12. So multiplying by 2 doesn't change the validity of the inequality. And if we multiply by an even larger number, the same would be true. What about dividing both sides of the inequality by a number? Let's divide both sides by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And again, 2 is less than 3. The inequality is still true. Moving on now, let's multiply both sides by a negative number, say minus 2. If I multiply 4 by minus 2, I get minus 8. If I multiply 6 by minus 2, I get minus 12. Well, is minus 8 less than 12? No, it isn't. In fact, the inequality has now swiveled around the other way. So minus 8 is actually greater than minus 12. What about dividing both sides by minus 2? 4 divided by minus 2 is minus 2. 6 divided by minus 2 is minus 3. Do we still have the left-hand side as less than the right? No, we don't. That is false. The inequality again has swiveled round the other way. Minus 2 is greater than minus 3. Right, let's see if we can summarize what's gone on there. Linear inequality summary. We can treat linear inequalities much like linear equations. However, note that multiplying or dividing the inequality by a negative number reverses the direction of the inequality. Right, let's put these ideas to work. 3 examples. First of all, let's solve 2x plus 3 is less than 11. Now, treating this just like an equation 2x plus 3 equals 11, what we would do is take the 3 to the other side. So we carry on in that vein, but this time it's a less than sign, not an equals, as it would be in an equation. 11, and when I take the plus 3 to the other side, it becomes minus 3. So 2x is less than 11 minus 3 is 8. X is less than 8 divided by 2. Now 2 is a positive number I'm dividing by there, so the inequality is unaffected, it doesn't change. X is less than 4. And notice that the answer is an inequality, it's not x equal to some value. X is less than 4 being the answer. Example 2. 3x plus 9 is greater than or equal to 7x plus 33. Right, we'll bring the x's to the left-hand side, and the terms that don't involve x, we'll take them to the right-hand side. So we have 3x. When I bring the 7x across, it becomes minus 7x is greater than or equal to plus 33 is already on the right-hand side. When I bring the plus 9 across, it becomes minus 9. Collecting terms together, 3x minus 7x is minus 4x, is greater than or equal to Plus 33 minus 9 is plus 24. Now, to find x, I need to divide by the minus 4. But if I divide by a negative number, the inequality swivels around the other way. So instead of being greater than or equal to, it's now less than or equal to. And it'll be plus 24 divided by the minus 4. So x is less than or equal to, plus divided by a minus gives a minus overall, and 24 divided by 4 is 6. So our answer is x is less than or equal to minus 6. One final example on linear inequalities. 5 bracket x plus 2 is greater than or equal to 3x minus 9. Right, just as if this was an equation, we start by expanding the bracket. So 5 times x plus 2 gives me 5x plus 10. And that is greater than or equal to 3x minus 9. Bring the x's to the left-hand side. 5x minus 3x is greater than or equal to, take the numbers to the right-hand side, minus 9 is already there, take the plus 10 across and it becomes minus 10. So that gives me 5x minus 3x is 2x, is greater than or equal to minus 10, and minus 9 collected together give minus 19. So x is greater than or equal to minus 19 divided by 2. Again, I'm dividing here by a positive number, so it doesn't affect the direction of the inequality. So x is greater than or equal to, a negative divided by a positive is a negative overall, so we can say x is greater than or equal to minus 19 over 2. And that concludes the examples on linear inequalities. We'll now look at 4 examples of solving quadratic inequalities. And you'll see from this page that I've already got the axes drawn for graphs. And it's a good idea to always draw a graph when you're solving a quadratic inequality. Example 4. Solve the inequality x squared minus 6x plus 8 is less than 0. First thing I'm going to do is factorize the left-hand side. So I'll have an x in each bracket, and I want two numbers that multiply together to give plus 8 and add together to give minus 6. So that will be minus 2 and minus 4. Minus 2 times minus 4 is plus 8, and collected together minus 2 minus 4 gives the minus 6. Now at this point I'm going to draw the graph of y equals x squared minus 6x plus 8. And I can see from my factorization here that if y is equal to 0, if the left-hand side is equal to 0, then there's an implication there that either x is equal to 2 from the first bracket or x is equal to 4 from the second bracket. And that's going to tell me where the graph cuts the x-axis. So I can mark on the point 2 and I can mark on the point 4. And I know this is a quadratic with positive x squareds, so the graph comes down like that and goes back off to infinity. Right, now the inequality I'm trying to solve is x squared minus 6x plus 8 is less than 0. So looking at my graph, if this here has to be less than 0, it means y is less than 0. And looking at the graph, you can see that the interval where y is less than 0 is the interval between 2 and 4. So the answer should be written as x is trapped between 2 and 4. And it's important to write it as a single statement like that because they both have to be true at the same time. You see, if I take a point here, it's less than 4. But you can see that y is positive then, not negative. So To make sure we're looking at this region here, we write it as a single statement like that. Let's move on now to look at example 5. Solve the inequality x squared minus 4x minus 5 is greater than or equal to 0. Again, we begin by factorising the left-hand side. X in each bracket, and this time I want two numbers that multiply together to give minus 5 and add together to give minus 4. So that will be minus 5 plus 1. Now then, I'm going to draw the graph of y equals x squared minus 4x minus 5. And from my factorising here, I can see if y is equal to 0 this time, then the implication is x is equal to plus 5 when this bracket is 0, or x is equal to minus 1 when this bracket is equal to 0. And again, that tells me where the graph will cut the x-axis, so I can mark on there 5 and minus 1. Again, the graph looks like that. And this time I want x squared minus 4x minus 5 to be greater than or equal to 0. So I want y to be greater than or equal to 0. And we can see that this time we don't get a closed interval, we get two half intervals, less than minus 1 or greater than 5. So we can say either x is greater than 5 or x is less than minus 1. And in actual fact, that should be greater than or equal to or less than or equal to, because of this slack inequality here. But it's important to separate them out, not try to write these as a closed statement, a single statement, because these can't both be true at the same time. Either x is greater than or equal to 5 or x is less than or equal to minus 1. Example 6. Solve 7 minus 6x minus x squared is greater than 0. Now this question has minus x squared in, and I don't suppose many of us are experts at factorising quadratic expressions with negative x squareds, so the best thing to do if confronted with an example like this is to just take everything the other side so the x squareds become positive. So the left-hand side will be 0, and if I just carry everything across the inequality, doesn't change the inequality, but we will have plus x squared on the other side, plus 6x on the other side, and minus 7. So now we're back on familiar ground. We can look to factorise the right-hand side, and I want two numbers that multiply to minus 7 and add to plus 6, so that will be plus 7 minus 1. Plus 7 times minus 1 is minus 7. Collect them together, plus 7 minus 1 is plus 6. And now I want the graph of y equals x squared plus 6x minus 7. From the factorisation, I can see that y equals 0 implies that x is minus 7, or x is equal to 1. Let's mark that on the graph. 1 minus 7. Now I've got the graph with positive x squared, so it looks like that. And I want this expression here to be less than 0. In other words, 0 has to be greater than this. So I want the part of the graph that's below the x-axis. And that gives me a closed interval again. X is trapped between minus 7 and plus 1. Right, final example. Solve 3x squared minus 2x minus 8 is greater than 0. So here we have one with more than 1x squared, so we need to know how to factorise quadratics with more than 1x squared. I have a video or lesson on this if you've forgotten how. But basically we need to multiply the 3 by the minus 8 to get minus 24. And I now want a pair of factors of minus 24 that add up to minus 2. And the appropriate factors there would be minus 6 and plus 4. Minus 6 times plus 4 is minus 24, and collect them together, minus 6 plus 4 is minus 2. And what I do now is I rewrite the left hand side, splitting the minus 2x into minus 6x plus 4x. And that's greater than 0. Just missed out the minus 8 there. So factorize the first two terms and we get 3x, x minus 2. And the x minus 2 should also be a factor of these last two terms if this quadratic factorizes. So what do I need to multiply x minus 2 by to get plus 4x minus 8? Answer, plus 4. There's the plus 4x, there's the minus 8. And that's greater than 0. Now then, how many x minus 2's do we have? We have 3x plus 4 of them. And that completes the factorization of the left-hand side. Now, when y equals 0, on the graph we're going to draw of y equals 3x squared minus 2x minus 8, when y equals 0, either this bracket is 0, and if 3x plus 4 equals 0, 3x equals minus 4, so x equals minus 4 divided by 3. Or the second bracket can be 0, in which case x equals 2. So that gives us the 2 points where the graph cuts the axis, 2 and minus 4/3. Normal graph, quadratic. And what am I looking for? I'm looking for this expression to be greater than 0. So I'm looking for y to be greater than 0, which is this part here or this part here. So the solution to this one is either x is greater than 2 or x is less than minus 4/3. And that concludes this lesson on solving inequalities.